Wait, you got like three shoelaces? Oh,
yeah, we did. Out of the middle of it.
Oh, that's just to see.
I know, it's so pretty. I had seen it in our camper. The first one. Yeah, like I was like way over there. I'm like, is that a skunk or something out there? Like, 'cause it was really, really dark and it was way out there. And then all of a sudden I saw something flicker. And I was like, oh shit, that's it. I was like, Jim. And I was all, Mom, I'm like, whatever. And she saw it from the ears. She's like, oh, it looks like a horse. Like the way its ears are moving. I'm like, oh, that one. This is way bigger than a horse. So like, whatever. He's like a range. And then it got up and we're like, that's a fucking moose. And then we went down to the lake later and
Probably was just
Silver bear, I mean, it's a classic name. When you're back with that name, it's so far away.
Oh.
It's like take a moment and recognize a special individual, Mr. Jacob Edson.
Jacob.
All right.
Yeah,
Blink-182.
there he is. What's it?
No, he was fun.
Speech.
Show the clutch slam.
All right.
That's kind of all over the court.
So last week we got into the air, started talking about. Alright, it worked. Started talking about. Talk to those shelves.
I don't know how I did this.
You cooking this presentation
It's super hard to teach off because you know how to do it.
Oh, wow. I should
I just know how to think of a way to make it make sense.
You'd be the first to do it.
Brian, did you draw SpongeBob on
Circumstances.
Yeah, I think that's
Cool. Alright, stop talking. Alright, what we talked about last week, Brian?
Reeve.
Who approves of Brian's answer?
He's not wrong.
That's
Literally true.
who signed you guys on? Brian, we must be more specific.
Talk about angles and vectors and setting up your rig points and span rigging a bit, stuff like that.
Anybody else got anything?
Friction.
Friction. Talked about friction a lot, right? When to use it, when not to use it. Okay. Remember, guys, I put this up here.
So many. It kills one of us because it's not you.
Okay. Yeah, so the biggest thing was our angles and the friction at play, and then how to set up our system in a way to maximize the forces doing compression, then tension into the tree, right? That's the biggest thing, is making sure it works with the structures that you have. And if not, change your angles and do redirects, add rings into it, or change it out to a pulley, double stuff up like the span rigging that we talked about. Okay, so we were on like kind of like the basic level. We did touch a little bit like the advanced stuff on the side for the span rigging. This morning we're going to, real quick, I'm gonna try and get this all done today, so bear with me, I'll be quick. But again, this is your guys' class. If you do have questions or want to talk about it, right, we can extend it one more week, so it's not a big deal, okay? All right, so we're gonna set up a Speedline first. We're gonna send the log down. We're gonna watch the load forces on that and see how it responds to it. And we talk about what the forces are going on up at the anchor point, because remember our sling angles. I don't know if you guys remember at the end when we brought up that span rig up to the top, and then how much those forces increase up there on the anchor points. That was the key thing, because you're like, oh, it's span rig, so I've got like, you know, it's a 20-pound log, so it's got 10 on this side and 10 on that side. But when you increase that angle and open that up, right, it really makes that log a lot heavier. Okay? And in theory, the percentage increase is infinite, because there's no way you're going to get it exactly at 180 degrees. There's always going to be a sag. Otherwise, you're going to have to pull that force. Okay? So anyway, you can really damage things with this. Okay, cool. So we'll do Speedline. Then we're going to change it into a controlled Speedline. I got the Reeve up there, so we're going to do a controlled Speedline. And then we're going to set up the Reeve system. I'm going to demonstrate how that works. And then we're going to talk about double blocking and how that works, and the pros and cons of double blocking and why we would do that. And then hopefully, that's it. That's the goal. And actually, guys, while I'm climbing up, it might be better on this side. Okay. If you guys want to move on to this side. Everybody see okay? Yes, no, maybe so. How about Joe? Alright, who's gonna be my handy helper?
Ready.
Gosh, he's been practicing. Come on, Josh.
Big dog.
Tie me a double fisherman.
Where at?
Woohoo!
Where?
Nowhere yet. All right. Hey, Josh.
Yeah.
You sound so excited right now. In a moment, things are gonna happen. All right, Josh, go ahead and come over to the GRCS.
Hey, Kevin, do you want me to use your camera?
No. Yeah, actually.
Like back there?
Careful, there's a battery.
I will be very sensitive.
No running.
No,
What?
right.
Well, we're not by a pool.
No heavy lifting.
You guys have terrible rules. I think it's facing backwards.
Okay, so what we have, I've kind of already preset some stuff. Normally, like for a Speedline, you can either hardline this. Let me ask you guys a question. We're setting up, let's say we're doing a Speedline, okay? Sorry, I said vertical or something. A lateral Speedline, okay? Normally we'll anchor it up top here, right? And then run it down to core raft or wherever we're using, and then we start sending them together, okay? What am I doing when I come up, over, and down to that anchor point? Increasing the force where? Up at the top, right? It's the same thing like if I'm coming up and over, right? So if I've got to hold that force, okay, or there's a force pulling down, I got to hold that force from sliding down. Nope, wrong. 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 Over the thumb. Gosh. You ran this like 1,000 times. Hey, it's wrong. You gotta go over the thumb through the fair lead. Because I'm gonna have you crank on it. So. Nope. Go back over. Okay, do one more. Move over the thumb. No.
Over the slipper deal, the rope grab.
There you go. Into the grab.
Like that?
Yeah. No.
The rope grab is like hard.
Huh?
The rope grab.
He gets nervous under pressure.
Yes,
There
it
it
is.
Give a good yank. You don't need him to pick that up.
Alright. Say it came out.
Just catch a deer rod.
Huh?
Smack it a couple times. Yeah, smack it.
What's that?
Yeah, Teddy.
What's that?
Yeah.
So like this.
Ready? See the smack? Yeah, you gotta go over the thumb.
That's the one.
Yeah, go over it.
It's not slowly.
Oh, seriously like that.
Jacob, please do that.
I don't know.
This is an under.
10 the slap first. Oh. Yeah, a lot slap. Alright, well, they're fair in the live job. Alright. So we're actually, if we go up and over, whether it's a limb or it's a ring or we put a device in there, right? We're always gonna have, because we've got forces right pulling down on this, we've gotta counteract that, hold it on the other side, which doubles up at our transition point, okay? Now, when can this be actually a good idea? Where we want to have go over a natural crotch or to install a ring or a pulley. When would this be a good idea?
If you're trying to make your
Okay, yeah, I guess that's a good idea, yeah. But if we have hardware up there, we gotta go and get it anyways. But if we're using a natural crotch, right, I don't have to retrieve it. Okay, good. I wasn't thinking about that. What else? Why would going up and instead of anchoring it to the point, why would we want to have it come and go over that, do a turn or change of direction?
You have a leaner that you're pulling on the top rather than pulling down.
Okay, so what would we do? Would we go back down to the trunk or would we open that sling gap? Okay, so we can maximize, right, our vector forces, whichever way the pulley is pointing, or the 50% of the angle, right, is our vector force. So if we can open that up and change our angle into a downward force and we're using compression as opposed to tension, right, that would be ideal. So in that case, I can, in theory, right, I could use a smaller piece of wood and get higher if I open that angle up and maybe I anchor it off to something off in the distance to another tree, somewhere that makes sense. You guys tracking with me? Okay, so like this, right, is what we have, and that's my vector, right? Okay, so I'm already in compression, so I'm pressing down onto my stem. If I were to not, and I'll just anchor it off, right? So where's my vector now? If I just anchor it right to here, where's my vector? It's to the truck. Okay, so just by changing that down, I've gotten into a little bit more of a compression than I am into that tension side. Okay. Let's say that now if I really open that up, okay, and I send it off to another tree or a truck or something like that off to the side, where's my vector points now? Straight down, right? Now I'm coming into the tree, and that's a lot better than being up top, yanking that thing over where my vector point is actually towards the direction of the tension, right? Okay, that's a good point. In that case, would you want to use a ring or a pulley or natural crouch? Ken?
Possibly a pulley, it creates less friction overall.
Okay, are we worried about friction? No, we're not, right? Okay. It really doesn't matter. Yeah, it's whatever you want to use, really. Ideally, you don't, unless you're removing the tree, right? If we're going to preserve that section of the tree in there, if we're natural crouching the top of that, then yeah, definitely we're going to want to install hardware because that will for sure destroy the cambium on the top side of the tree, and that will cause a lot of harm. So that's the only time where, not the only time, but where I would consider putting hardware in as opposed to just natural crouching. Okay? Other than that, it really doesn't matter. Because of friction, right, the movement might change a little bit, but it doesn't matter because this is essentially static. The only time it gets tightened up in Speedline instances, okay, is when we're tightening up the load. That's it. And so it really, we're not lifting, we just need that anchor point to come up, and that's it. So a lot of the lift is going to be on the working side, not the other side, so we don't really have to play any part. Okay. Okay, give me, now in Speedline, right, do we want it super tight? Or do we want it loose? How do we want to set this up? Right, so if I'm rigging off a limb, right, let's say I've got this limb's already off, I want this log, and I'm going to send it down. Like, do I want to clip into this and then have them get it really tight? Or do we want it loose? Tight? Okay.
Depends on if you're trying to steer something.
Yeah.
Good. Very good. No, okay. It depends on what I want it to do, right? Because in theory, right, I don't want it tight all the time if I don't have to. But if I gotta clear obstacles, okay, I want to find that balance of what's tight and what's too tight. Okay, we want to find that happy where I can get that clearance and send it the way I want it to, but I don't want to overstress my anchor point because again, is it really like you can see like he hasn't even put any. They hardly like look how slack this is, right? Look at what we have on there. We already have almost 100 pounds just by the rigging itself. Okay, we haven't even tightened up. But yeah, go ahead and lock that off. Yep. Yeah, just go around and pick it up a bunch of times. Yeah, now go to the other pigtail. Go to the other pigtail. Go to the other pigtail. Now go to the other pigtail. Yeah, go to the other one.
This is gonna pull this off.
Go to the other one. Now go to the other one. Alright, that should be good. Alright, now go to my 5 to 1.
I don't know if that's the.
Bastard.
Come on, Josh, I'm tired.
Alright.
It's Start pulling on it. Okay, hold that. Good. Let's go a little more.
Wow, that is strong.
Let's
Yeah,
go,
dude.
let's go a little more.
You're doing 30 pounds?
Alright, that's what it feels good. Alright. So just on the 5 one, right? He's barely struggling on it. He's able to generate 400 pounds just by tightening that up. Okay. So go ahead and let go. Let's get it'll stay. All right. So I'm just gonna put the load on this, and then we're gonna watch how that increases just by this little lock. Okay. We have 360. Yeah, look at that. It's not that big. But if we were to put a 200-pound log or 150-pound, which is where I am, right? We're up to 700 pounds pretty easily. So you can imagine converting that 500 to 600-pound force into a tension pull off the top of the trunk of the tree or the stem of the tree, or put that into compression force, okay? Because that's where those vector points are important, right? Everybody tracking with me? Okay? So I would rather, unless it's all circumstantial, like Lil said, what do we want it to accomplish? But I would rather have mine, if I can, I would rather put it in a compression than a lateral tension force onto that. Okay? You look confused.
Done?
No? Okay. You said that.
Yeah. No, that's just my face.
Cool. Okay. Okay, everybody got it? Okay, go ahead and loosen up, Josh, please. Actually, yeah, loosen up. Okay, I need another handy helper. Who's gonna help me? Come on, Jake. So that's Speedline. Everybody understands Speedline is pretty simple. What we're gonna do next, yeah, give me quite a bit, please. We're gonna do a controlled Speedline. Yeah, sorry, more slide. Yes, please. Okay, I got this one first.
Over there.
No, just take the 5 one off.
Take the 5 one off.
Back here.
Oh, it's the GRCS.
Yeah, yes. Yeah, that way, Alex.
I know how your pencil stuff works. See 2 tabs.
Pull down, slide the cam up and out. And you can set that down, Josh, gently. Is that what we're completed? Okay, so in this setup, right, in Speedline, when we're clipping things to it, okay, and the limbs are attached, we make our cut, it slides down, it's pretty much uncontrolled. We're controlling the direction and hopefully where it lands, but there isn't any control. So larger pieces are a little more difficult, as well as sometimes, right, let's say the piece, right, let's say this is my piece and I'm going to take this log off, and I'm about 2 feet below it is the house, okay? No matter how tight I get that onto my 5-to-1, if I'm doing Speedline, right, what's gonna happen once I finish cutting this off and it's attached? Right, it's gonna come up, and all that tension is out. Now it's slack. It's gonna slide down and land not ideally where I want it to. So having the ability to control it is, I can control the descent off of a pour wrap on the backside. I can make my cut. It's gonna loosen up, and then either on the 5-to-1 side, or if we have a GRCS, I can then get rid of the rest of that slack, ideally, right? Then make my clearances, and then send the piece on down, okay? All right, Josh, on the GRCS, please. Go ahead and take that off. And in this case, just like 2 wraps on the baller this time. We're not moving heavy. We got some slack. Okay. You don't have to use the Reeve, but I'm using the Reeve because we're going to set up a Reeve system here. Hopefully real quick. Okay. So you can use a pulley. You can use the carabiner or sling, right? You can do this as long as the pieces aren't too big, and attach your control line to the piece itself and butt tie those off. This is a little quicker. I would avoid using something like this unless you have really good angles, because it will get stuck because of the drag of the rope. Especially the smaller pieces, the pull on this is going to keep that piece from going down because of the friction on the carabiner. Okay, so it might mess your system up. So if you can, if you're going to do a controlled speed line, I would advise just taking one of your blocks, clipping it here to the deadeye sling, tie that off to the piece, and then tie the butt tie to the piece itself. Okay, that's one way. Or you can tie it to the block or the sling if possible, if it doesn't interfere. Because again, this side is not seeing a lot of force. It's just controlling this scent. Okay. Okay. So everybody copy on that? All right. So we're gonna pretend we're gonna lift this log off. So go ahead and pull up, Jacob. Stop, no, you're too trump. Pull that back up, right? Okay, hold that. Okay, so the control line, right, is gonna keep this from going down. And then Josh, if you want to go ahead and probably just pull it. Alright, so he's cranking. Okay, hold that. Go ahead and pull, Jacob. You can control where that piece is going. Go ahead and pull a little more. And keep it centered to give you maximized control. Now, if we're going to send this down, right, it's probably not going to land where we want it. So we can continue to, go ahead and keep pulling. We can continue to pull the piece up until we gain the clearances we need. Now, Jacob, we can send it down. Right. Now we have a controlled descent, and we're able to get the clearances we need, especially on those lower pieces, right? If you can put this on a normal working scale, limbs down here, and I'm going to be 30, 40 feet up in the air, that is a huge deviation into the deflection of my high line, right? So if I didn't have any control, that's just going to go thunk, and it's going to hit the ground. But here with the control, I'm able to static lift that in a sense, hold that on the control side, cut it, get it up into the air where I want it to go, and then send it down and land it in the direction I want this to land it. And not all of us are carrying GRCSs, so in essence, you could do what Josh is doing on that side with the 5-to-1, or vice versa, right? You can, where the GRCS is, you can attach a fair lead or a block, run that laterally across the ground to another anchor point, install your 5-to-1 laterally, and then that side can become your lift side. But again, you're adding a little bit more hardware and equipment. It's just probably easier to do everybody understand?
Do you avoid using trucks or skids
Yeah.
to lift? Just over.
Yeah, 100%, guys. Like even using unless you're, I would avoid as much as possible using like the winch on the chipper, pickup trucks or the mini skids. Our mini skids are around 4,000 pounds. They have a high pulling force, right? They can probably pull more than their weight, obviously. So you can imagine just by Josh barely on the 5-to-1 putting tension on that. With the mini skid, you can hit some. Especially if you're in that change of vector or change of direction, you have anchored on that, you can get some high peak forces from there and break your system out, even off of smaller loads. Okay, so yeah, be very, very mindful how you do it. So I've used winches before, but man, I'm super delicate on it. I have it low idle. I don't have it full idle. I'm giving it a little bit of pull, right? Because I know how much I need to lift that off, especially in this case, right? Especially with equipment too. Like let's just say I'm rigging this piece off. You can imagine, so the purple line is our high line. That's where the winch is attached to the piece of equipment. It comes down and then out, right? My vector is this way, okay? And if I make that cut, in essence, if I have too much tension, that's launching up into the air. I'm in the way, my saw's in the way, I can bring that up into me. It can launch and just cause a lot of dynamic movement onto the system. So just be super, super delicate if you are going to use the wrench for that movement. Right? That's why like 5-to-1s, you can accomplish a lot without that equipment. It is a little more labor intensive, especially if you're using the GRCS too. But just be mindful of like that is a lot of tension that's going to be there. Okay. Any questions? It gets higher. Anyway, all right, bring it back. Okay, so what we're going to do, now we're going to change. Yeah, I didn't do that. Okay. All right, go ahead and give me, bring that back up here, Jacob. All right, Josh, lower down. Very good. All right, what we're going to do is, we're going to do the Reeve system. We're going to do it the Reeve or the Norwegian Reeve and all that, whatever those fancy names are. So right now, right, we're able to control the descent, kind of gain some lift, but we're limited to our anchor point, right? And then where we want that to land. So we could, if we wanted to, if we had good angles, once the piece was where we want it to be, we could lower down on the high line side and then touch that down and land the piece where we want it, but we're kind of stuck in that area, okay? If we just change, which is what we're going to do, we're going to change, I'm going to get a higher position point just for demonstration. We're going to set the Reeve to where we use the high line, not only as the, actually I can't, I need an extra rope. Dang. So I'll set that up. Josh. Yeah, we'll keep the purple ones higher. So this one again, as we're building on complex systems, the more gear that's involved. So this is going to continue to be our high line.
No, we're back. Yeah. Wow. Sitting. Sit.
On the, Jared, if you pull my tailgate down, right in front of you should be a pulley carabiner. Yeah. Rolling lock Z. I'm just gonna tie it off just for
Jeff would be very upset with you.
he would be so mad if he saw this video. He's like, he's unblinked!
It's only me.
Tie it in, Jeff, calm down.
What is Jeff?
Okay. Hey, Red, hold on.
It's like every time you
Right, first day.
it's like Google how to parallel in that right? So we did
Hey. Alright, we're ready. So what we're gonna, so the top purple's gonna be our high line. So this one's always gonna be static. So in this scenario, when we're doing the Reeve system, your high line, the toppest one, is always gonna be static and tight. So you're gonna want to, and I didn't have another way to enter that. static, right, you would anchor that off, use a 5-to-1 to pre-tension that. That one stays exactly in the same spot. It doesn't get loosened up or tightened up, okay? Because this is what the pulley system is going to travel down. So that's going to be in the area of your landing system. The next line below that is going to be your control lines. I would recommend, normally you're going to want one on each side. I just have the orange one in this case just to show you guys. But in the Reeve system, because that one stays static and the lines are usually pretty high, you're going to want the ability to pull one direction and the other direction and not rely on gravity to take the thing down, because as you'll see, there's going to be quite a bit of friction in the system. Okay, and then the one below that, this is going to be the lift line. So this is the one you're going to want to have lifting abilities onto it. So either onto a GRCS or to your 5-1 to be able to pick the load up. Okay. All right. So with our control line, which is orange, right, this is going to keep it from going down. The purple line is the high line. That's the travel line. That's where it's going to go. And then Josh, you're going to show off your muscles, okay? Okay. So as Jacob holds, right, he's going to hold it wherever it is that we're picking the load up. Right, go ahead and start pretending to lift that.
So I got it.
Yeah. No, just keep it, just lift it back.
Man.
There you go. Okay? So we can, our travel height can be wherever we want it. It can be down, it can be up, okay, it can be wherever we want it. What's neat about this is now, I don't know if you guys can see it, just go ahead and hold static now. Your line. Right. Don't let it move.
Alright.
Not even an inch.
I can't.
I'm relying on you, Josh. Okay. So what's cool is, as Jacob lets off on the control, it's not you, Josh.
I'm
Okay. This can travel down, and then we can also lift up
That's crazy.
and control that. Normally we would, but I'm dumb because I put it on the wrong side of this cable, right? Road management's key. It's traveling along this line as well as this line up top here because it's running through these pulleys here. Okay, so go ahead and pull back, Jacob. See what's happening there? All right, let it out. Yeah, I got it. Hold that. Did everybody see that? Okay, so technically this is also acting like the high line itself, because the load is traveling down the lift line as well, okay? So in this case, right, do we want friction or do we want efficiency? Who says friction? Who says efficiency? 100%, very good job, okay? Right, because we have a lot of change in directions here. Okay? We have things we have to slide down, so the more efficient we can make the system, better off we're gonna be as far as making that travel. So as you guys can see, I have 1, 2, 3 points of attachment for change of direction, right? So that's 3 times the amount of friction in the system. That's why having a second pull line on this top side here to be able to haul that off to the direction I want it to go will make it a lot easier for you guys. So I recommend, unless you have like a crazy angle, like you're up on a hill or something like that, and you need to do a Reeve system, anytime it's up in like a 25, 30 degree area, definitely add that third line. So gear intensive, but super cool because it's nice is if, so go ahead and pull it back in it. Right, so we, in theory, okay, not theory, we've actually done it. So control line holds, just like with the controlled speed line, right? Now, instead of using the high line to lift the piece, right, we're using the third line, okay, to lift the piece up vertically. Okay, let it down. And then it travels, and then now look what we can do. Now I can take this and then I can lower it down to the ground. Okay? And anywhere that travels along it, I can pick and lift that thing up. I can pick it and lift it back up and have it travel along that system. So As I've demonstrated, right, obstacles are key. You want a nice clear line of sight, make sure all your lines are in order. If this one is wrapped, okay, and twisted, again, this is your lift line and part of your travel line, that's gonna cause issues with the Reeve system itself being able to function down there. So you want nice, clean lines, everything's lined out, nothing's twisted. You don't want them separated. They all need to be in the same direction. Because right, if it's separated, right, and I have this, my Reeve is going to be looking like this. Now I'm traveling along the cheek plates of the Reeve system and not the way it's designed to be used, okay? And then that'll make the lifting side a lot more difficult. Okay? All right, cool. All right, any questions on the Reeve? Alright, last one. We're going to do double block. Yeah. Alright, go ahead and take the log off. Or the log. Do you like that? No, I'm going to use the just for the thing. I have a bunch of pens. Okay, so double blocking, right? We're using mechanical advantage to our advantage. Because as we've been learning through this whole entire thing is, right, angles and using our systems together is really going to, I actually use that one. Sorry. I'm done with it. So they can see it. So double blocking can be used in a lot of different scenarios. Okay. Why, Stanley?
That's how I understand. Oh my goodness. Get it out of your tax rate.
they get it from?
Oh.
They wanted any excuse to call him Daddy.
Yeah, the other side is this second D and Y.
The B,
Yeah.
In the morning, it's like trying to put your teeth.
So this is double blocking. This is when we're getting into big heavy wood, or if we need to lift big sections of wood on X-current trees, right? We want to double block that, where we can pull that up and then lower the piece. So this one, you can do it in a negative and a positive rigging situation. But in this case, I'm showing you the negative side. It's not negative in like it's bad, the negative rigging side, okay? So what would happen is, right, if we have our 20-pound weight, and I do a negative rig into my rigging block, which let's just use our imagination today. It's one reason like we would have a rigging block here, right? Because fixed cheap plate pulleys are not designed for impact. They're designed for static lift, like we talked about in our rigging inspection and class, okay? So anyway, so this setup, just imagine appropriate gear, insert here, okay? Thank you. So normally our 20-pound, right, it would come down. We would have with our amazing tool Josh on the rigging line to control that, right? That dynamic fall to cushion it, slow it down. So for our 20-pound, in essence, right, we can see peak loads pretty high on this side, just by negative rigging it, right? So we got 20 pounds, we got whole 20 pounds, we have 40 pounds, so it doubles. Plus, E equals MC squared, and the load forces and potential energy and all that, it can get up into the 300 or 400 pounds, right? Real quick, okay? So what we did is we just incorporated, like, just like mechanical advantage, right? We took our force and we compounded it. So just like with our rigging or our 5-to-1s, right? Our force is our input. By adding pulleys and changing direction, right? We can increase the load that we put on them. But also we're reversing that to where the load, our input is going to be the force. So we can reduce the force by adding the same thing, just reverse it, okay? Less pounds because of the load forces. Yeah, clear as mud, right? So anyway, you're gonna run that up, make your cut. I'll probably put out a video if you guys that are probably confused for it. It's gonna come down. This is what you're gonna end up with. Okay. At the same point of your pulley system, this is the right, so anchored comes down to the load, back up down to our friction device, the border wrap with the GRCS. So in theory, right, we did the same thing like we did last week when we demonstrated where we did the span rig. We're basically span rigging in this situation. So 20 pounds, 10 minus friction, okay? So this only has to hold 10, this only has to hold 10, this only has to hold 10, so this becomes 20. So in theory, the force generated by our dynamic load, instead of it being doubled, it's just what it is, okay? So by adding that fluid, we've cut our load forces in half at our primary reading points, okay? Now, who can see an issue with this system besides setup and complexity?
Smack your holes.
What's that?
Smack your holes.
Okay, smacking the pulley could be one. Okay, so if you don't line up right, hardware can get damaged. Anybody else?
You're gonna hit the groundie.
Well, it's the same. It's the same thing. If I was just negative reading, it's a lot of rope. Okay, so right, so we did two things, right? We've decreased, we cut in half basically the load forces at our anchor points, right? And we've also increased our rope need. Okay, so if our groundies are not, you guys aren't communicating, and he sees this massive log coming off, right, he's gonna freak out and probably be a little harder on the rigging line, right, not let it run as much. What that's gonna do is you're definitely gonna get shock loading, and if he doesn't have enough, this eats a lot of rope, right? Because essentially we're using 1, 2, 3 legs. So if I have a 100-foot line, how far can I get to the ground with a 100-foot line? This is a test question. Huh? 33 feet. Okay, so if I have only 100 feet of rigging line, the maximum drop that I can get is that 33 feet. 33 feet is not that far, okay? So make sure you have enough rope to reach the ground if you are going to double block this. And then also make sure to communicate with the groundies like, hey, less wraps, let it run a lot. Because this, you're tripling the amount of rope that's going to run through their hands, right? Because it's got to run. So therefore, if it doesn't, right, we're not going to be able to push it that far.
Are you kind of typically using this in situations though where you don't want to let it run at all? Because it stops it a lot faster than
You
just
can.
a normal negative rate?
You can, yeah. So if you're in a position where tight corners, right, you can't let it run. You want to limit the amount of rope stretch too, right? Because rope stretch is going to be involved. That's in play. Not just our rope, but also our sling is going to stretch. It's going to tighten up. So yeah, if I needed to shock load this, yeah, double block it off, right? Because now
the only times I usually just stop it fast.
yep. It's really rare in Colorado to use double blocking, just because the trees aren't monstrous. But when you get to Cali, like you're talking 4-foot in diameter logs that are coming down. We use this all the time, so it's a really good tool to have. We could be 100 feet up, and I'm cutting 36 DBH wood, sending out 15-foot sections at 100 feet, which is insane. But anyway, so it's got its place. What's nice about this is the ability to, like, if I did have a high, let me get out here, but if obviously we would leave the spar, but if I'm lifting, if I want to lift, let's say I've got a 10-foot section on this log here, I can basically put that sling there on there, pull high, undercut, lift that piece up, and then lower that down, which is kind of like span rigging, but you get that 3-to-1 mechanical advantage as far as being able to lift that piece up. Okay? Any questions?
So the most often, I guess, like, yeah, you would most likely use this in a situation where you would need to lift the wood as much as you would need to lower it, correct?
Correct. Yeah. Especially for here in Colorado, it's more for lifting than actually letting it run. Or like Luke mentioned, great idea. Like if I know my rigging can handle what I'm doing, but I need to shock load it, right? Yeah, let's be safe. Let's add that extra stuff into it, so then we can make sure we're not exceeding our working load limits of our line. So we'll double block it. Okay. All right. Cool. Any questions? Stay.
Okay, guys, we're gonna draw for the Google review for June. I have 2 gift cards. So then I'll let you draw.
That way they can't get mad at me.
Alan, but you have to be here to win. So. Then I got Ness.
So that's a $50 gift
Or
card.
that was 25, and then first place is a 50. To Nacho Matrix.
Gil.
Awesome, guys. Keep up the good work. You can see who's entering in for July up there. You guys killed it last month. We got, I think, over 15 reviews, so that's awesome.
We're at a 4.9 too.
4.9, yeah, exactly.
Sick.
And if anybody has Yelp, leave a Yelp review for us because that's what I'm trying to build up even more. Because we're at 4.1. Yeah. Awesome job, guys. Have a good day.
Thank you.
Yeah, thank you.
Job for so just so you guys know, the points get erased for the month, but they're total tallied all together for the grand prize. September, price end of September. So just because you didn't do it now, right? All of that, all the stuff you put in, they all you put into the grand prize drawing. It's going to be up. So keep it up. Thank you. And it is important, guys, to get those reviews. I know it's hard for some of the commercial guys, but hey, you see somebody, hey, I'll give you a cookie.
Yes, we keep cookies every day.
Hey, that branch, I'll put that on for you. Alright, so that's end of rigging. Next week, we're going to transition our brains into pruning. We're going to go in depth, and I think what I'm going to do is we're just going to go through the ISA certified arborist. That will avoid lame guys like Brian not showing up on Saturdays. I gotta be there. But also, right, I like my Saturdays too, but then everybody's getting the knowledge because people, we make plans on Saturdays, so I think the best thing is we're gonna go through the ISA book, talk about true physiology, biology. We're gonna skip some sections that are irrelevant, I think, as far as what we're doing, like the tree planting. We're not going to go on the tree planting. We're talking strictly mostly the pruning side of things. And then in there, I'll try and figure out a time to interject PPQ, the prescription pruning qualification, and their standards, because that's going to be something our municipalities are going to be requiring us to do. Their product works to do it. So it's completely different to what we're used to. But I'll explain that once we get to it, okay? Cool. So shift gears. Plan for next week, nerd out, take notes, have coffee. It is going to be a lot of me delivering information to you, not a lot of demonstrating. We'll have it on the TV, but again, it's going to be, so be awake. It's really, really, really cool stuff, really, really important. We can take as much time as we want to on it, ask questions if you don't understand it, figure it out together. I'm not an expert into it, so yeah, because like there's cotyledons that have changed and their description and plant ID has changed, and so it's new to me as well, okay? Okay, all right, let's share the what's up.
Thanks.
I'll bring it in.